Thanks for the introduction. So yeah, today we're going to talk about voice IoT edge devices and how to navigate the edge cloud bridge. We're going to talk about different architectures when architecting your device, hopefully, and we'll do 3 live demos, so hopefully it will be interesting. My name is David Von Thenen. I am an AI ML engineer. I've been in the space for quite some time. I've done a bunch of stuff relating to like NLP, where I worked at a few startups, although I have a lot of other interests in like IoT Edge, medical, vision. So love doing AI ML related things. Prior to that, I was in the Kubernetes and CNCF ecosystems, so contributing to open source Kubernetes. And prior to that, I was also doing backup recovery solutions for virtualized environments, specifically VMware vSphere. For the agenda today, we're going to talk about IoT edge devices, specifically voice activated devices. And we're going to kind of like just level set and define what they are. You have them in your home, you probably use them. And then we're just going to go into different architectures and different considerations when you're building your IoT or edge device. We're going to talk about 3 different kinds of architectures and going to have 3 different demos live for you for each of those architectures, and then hopefully end with some Q&A here. Voice IoT edge assistants, what are they? So just like you might expect, they are in your home. So we have a couple pictures of some that you're familiar with. So like right on the right-hand side there, you have like an Alexa. The one in the middle, right, you have the cool new Meta Ray-Ban glasses. And then the one on the left there, you might not be so familiar with. It's the Rabbit R1. But all of these are edge IoT edge devices, and they are also voice activated. Some other, like the Meta glasses and the Rabbit R1 have video components, so they're multimodal, but they're edge IoT edge devices. What makes up a voice activated edge device? So it's really 3 main components. The first one, because we're interacting with voice, is to take our voices, the commands that we're speaking, and convert them to text. So it's often called like automatic speech recognition. Effectively, what you're doing is transcription, taking voice, transcribing what I'm saying to text. Then the next component is we take that text, we pass it off to these days, an LLM, could be a RAG agent, some large language model, to process the command or like what it is we want to get an answer to. Then finally, we take that text that the LLM generates, and then we send it through a text-to-speech component so that we can take the audio that's generated and have the device respond to us, right? So we can hear the response. So again, 3 big components. The first one, speech to text, gets processed by an LLM, and then the text-to-speech so that we can hear the response through a speaker on a device. So now that we kind of just have like a very basic understanding of like what an IoT Edge voice assistant device looks like, let's talk about the meat of the presentation here. It's like different architectures and kind of more importantly, the different considerations and limitations that you have when you decide to architect your device and your solution and your use cases that you're trying to solve. So kind of before we get into these different architectures, we need to talk about IoT edge devices themselves and like what their limitations are. And the biggest limitation is size, right? You have a device that lives on edge. Yes, they can be very large, but more often than not, they tend to be very small. Small as in physical size small. And because of the physical limitations on the size of the device, you have many, many different constraints. So you might have a device that has very little CPU. There's going to be a finite amount of memory you can pack into a small form factor. It may or may not have a GPU. If it does have a GPU, do you have enough power to power the entire device with that GPU? So all those things considered, what architecture or how do you architect a solution in your device to solve a particular problem? And it all comes down to the use case. What use case, what problem are you trying to solve? And from there, you kind of like get a sense of like what the requirements for the device are going to be. Like, what does it need to have? Does it need to have a GPU? Does it not? And based on the device and like the device requirements, you're going to then learn like what the cost of your device is. And the cost, definitely can play a huge role in how how much adoption you're going to have on your device, right? What is the cost that it's going to take for your user of the device to buy into that, that solution? How much of an impact can that be? So like the best example of that recently has been the Vision Pro from Apple, right? It was a very big device that, right, goggles you put on your head, and it cost a lot of money. And because it cost a lot, right, the amount of people that wanted to buy into that solution and that product was significantly decreased. So all of these things that you have play a huge role in like the adoption of your device, the solution, and the device that you're going to build. In addition to all of the things that I've already mentioned, there are a bunch of like, what are the use cases for your device, right? Like what kind of performance profile do you want your device to have? And since we're talking about like voice activated assistants, so like one of the biggest ones is if I give it a command, a verbal command, like does it need to respond right away? Or is it one of those things where it can sit and I can get the answer 2 or 3 minutes later, right? So you have responsiveness requirements. And then you may have security or privacy concerns like intellectual property, confidentiality, personal identifiable information. If this is a medical device, you might have to be concerned about things like HIPAA, right? And so all of those things play into like what your solution is and what your device is going to look like. And although we're talking about voice assistants, it may have a webcam, right, to take pictures or to take video. So, the modalities of your device will play a huge role in what your device looks like. Kind of bringing everything together, you're doing an impact analysis of like, what is the device hardware going to be? What do I need to process on the device? What things can I offload to other cloud infrastructure, other solutions, SaaS platforms? But ultimately, kind of like walking backwards again, those things all impact the user experience and like how much is it going to cost? Will they even want to buy the device? So all of those things will ultimately impact user experience and what your solution and architecture for your solution and your device look like. We're going to talk about the first of three different architectures. And the first one is like, what does a lightweight edge device look like? Like what does that architecture look like? And in this case, right, if we take a look at the image here on the left, we can see that a lightweight edge device, just kind of like as the name sounds, it doesn't have much resource on edge, right? It has, in your device, you may have a little bit of CPU, you might have a little bit of memory, it may not even have local storage. But because we're talking about voice assistants, it's going to have a microphone and has a speaker to process the audio, right? Both input and output. And in turn, because your device is very small, lightweight, and inexpensive, you're going to heavily rely on cloud services. So that's kind of like the depiction here on the right-hand side. You're going to rely on a lot of cloud infrastructure and a lot of SaaS platforms to provide the meat of the processing for your particular device. And instead of just talking about it, I think it would be kind of very interesting to just show you it, right? Give you a demo of what that looks like. And so in this demo, you can see from the picture here, we have a web browser, which is going to represent in the picture, just going to represent our client. We have our client application. It's going to serve up some web pages. It's going to take in the audio from the microphone. It's going to play audio that comes back from our server application, which the server application is going to handle all of the processing, right? It's going to take the audio that we get from the client, do the speech to text, take the text that we get as the result, pass it to the large language model. Large language model is going to give us some text output, right, our answer. And then we're going to, in the server application, process the text to speech to get the audio for playback in our client. And so this is exactly what I'm going to demo here. So let's go ahead and give this a try. So this is a server out there in some cloud infrastructure on DigitalOcean. And I'm going to go ahead and run the server application right now. And I'm going to go ahead and run our client application, which is going to give me this URL right here. I'm going to go ahead and open this on a web browser, refresh this, and you can see the UI here. So as soon as I click the start button, I'm going to ask it a question. I'm going to get a response, right? Again, all of the processing happening on server side, and then get the audio to play back here. So let's go ahead and give this a try. Computer, tell me something interesting about Los Angeles.
California is a large state on the west coast of the United States, known for its diverse geography, including beaches, mountains, and deserts. It's famous for its entertainment industry, particularly in Hollywood, as well as its agriculture and tech innovation in Silicon Valley.
Okay, so pretty cool, right? So now if we go ahead and take a look at our console output here, right? This is our client side. You can see that we just served up the web pages and did literally nothing else. Now, if we go to our server component here, you can see that we did most of the processing on the server here. We took the audio, again, from the client, streamed it. It did the text-to-speech on server. The LLM got the text, provided us the answer, and then did the text-to-speech, converted it to audio, and flushed it to our client web browser, which we all heard the audio. So this is an example of a thin client architecture, or lightweight edge device type architecture. Now, on the opposite end, we have a high performant edge device. So this device is something where you have a ton of resource on edge. So if you take a look at the picture on the left, you have an edge device where it has a ton of CPU. Maybe it has some disk, a bunch of memory, and maybe it even has a GPU, right? If you want to land like an LLM on edge. And if you have a GPU, you need to have all the power requirements necessary to run your edge device. You know, keep in mind, having more resources, again, makes your device more expensive. But like the trade-off is you get to process more and more stuff on edge. And it still may have, your edge device may still connect to cloud services like cloud infrastructure or SaaS platforms. And so like maybe one example of what you might want to do is process everything on edge and then just use like cloud infrastructure for like auditing purposes. So like just keep like a trail of like the interactions between the person using your device and the device. And so instead of talking about it again, let's go ahead and take a look at like what that looks like. So for this demo, we're going to do, again, high performance edge device. And you can see this box is now a lot larger because it's doing a lot more things, a lot more processing on edge. So we're going to, again, process the audio. We're going to take the audio and we're going to do the speech to text locally on the edge. We're going to take the text that's generated and we're going to pass it through an LLM that is running on edge. Then we're going to take the result, and I'm going to use Llama in this case. So Llama 3, I'm going to end up passing the result of that to the text result from the LLM to the text-to-speech component, and then play it in, on the device here so that we can hear the result. And we're only going to use the server side for auditing purposes, for reporting. So we're going to take the question I'm asking the LLM and the result of the LLM, and we're just going to pass it to the server for auditing purposes. So again, remember, high performant edge means far more expensive device. So all right, so gotta navigate to the directory here. And I'm going to go ahead and run the server component. And I have an LLM already running. So this is Llama 3. You can see that it's just sitting here idle. It takes a while to start up, so I started it ahead of time. And then I'm going to go ahead and run the high performant edge device. And let's go ahead and take a look and see what that looks like. Tell me about California.
Sure. I'd be happy to help you with your California-related inquiries. Can you please provide me with more details on what you're looking for? For example, are you interested in exploring the state's beaches, cities, or national parks?
Okay, so here on the client window, you can see And actually, I'm glad this actually kind of didn't work exactly perfectly. So here you can see that I said the command, tell me about California. It didn't transcribe it exactly great, but the LLM was able to figure out what I was kind of asking it. And it gave me a response. And then we heard the the audio playback in the speaker here. So because you're running stuff on Edge, even when you have a GPU, in this particular case, I'm running on my laptop, the models and the things you get to choose to run may not be like the 70 billion parameter model, So like the LLM, for example, I'm running the 8 billion parameter llama. Even though you might be running a GPU, you still have constraints on like what you can run. And maybe those things might not be the best thing to do transcription, for example. And that's why this particular thing didn't come out exactly right. Now, on the server side, right, we were just doing basic logging or auditing. And you can see the transcription that got transcribed got sent to the server here. You can see the post for it. And then the response from the LLM, we basically just did another post to do auditing for auditing purposes. And then you can see that just for completeness, you can see the post on the Llama 3 here to verify that you got a 200 response on the result. So high performance edge device, right? The idea is you run on Edge, you can run a lot more, and you have little reliance on cloud resources. Usually in the real world, though, everything's kind of sitting in between, right? You have lightweight edge, high performance edge. In the reality, it's somewhere in between. Maybe it leans towards one direction, maybe it leans towards a little bit more towards the other direction. So in this particular example, right, we have some CPU. We have more, maybe perhaps more memory than we did in the lightweight edge device. Maybe we have storage, maybe not. And we still use cloud services, right? And kind of the idea is you pick and choose your battles. You pick the things that you want to do and run on your device. And there are some things that you maybe not super critical to your business. And those are the things you defer to cloud infrastructure. So this could be anything from like the speech to text or the text to speech. Maybe your business and the value add that you bring to your users or your customers aren't the speech components at all. And so you may want to defer that to third-party providers that do a far better job than you trying to run your own speech to text or text to speech models, right? But the point is you rely a little bit more on cloud services, and you get to pick and choose what your device looks like and the things you want to defer to cloud solutions. So for the final demo, we're going to go ahead and run this hybrid edge demo, which we're going to have we're going to bring back the client application in the form of a browser. And we're going to do the speech to text and the text to speech processing in the client. And we're going to do it by running and calling out to third-party providers to do those pieces. And the reason why you might want to do that is if you have more networking bandwidth and a little bit more processing capability in your client, deferring that to the edge is, and using third parties to supply that functionality distributes the load that you would normally incur on the server, and you push some of that work out to the client, right? And in this particular case, all of our intellectual property or the value add that we're bringing is going to be done in the server side, right? And in this particular case, I'm going to use the DigitalOcean GenAI agent, which is effectively just an easy button to create a RAG agent. And the agent that I created was a Southern California travel agent. And this RAG agent could connect to other ML models. Maybe it knows a bunch of things about travel related stuff in Southern California. So you could have a bunch more things running on the server and process all of the value that you bring to your customers in the server, and then just provide the result to your client, have it do the text to speech, and then play the audio. And so this is the demo that I'm going to show you right here. So for the last one here, we're going to do the balanced one. I'm going to go ahead and pull up the server side first. So I'm going to run that. Going to go ahead and run my web component client. Oops. Ooh, I can, there we go. And then let's go back to our UI. Going to do a refresh. Excellent. So I'm going to go ahead and click this. Again, we're going to ask our travel agent something cool to do in Southern California, and we'll see what the response is. Computer, what activities are there to do in Long Beach, California?
I'm excited to help you plan your Southern California adventure. Whether you're looking for beach relaxation, city exploration, or outdoor thrills, what type of experience are you looking for, and which part of Southern California are you interested in visiting?
All right, so if we take a look at the console output, you can see that I did the text-to-speech and the speech-to-text processing here on the client side. And then if we look at the server side component, we can see that we did get the answer from our DigitalOcean generative AI agent, so our travel agent. And this is the result or the output that we got from it. Very, very cool. The end here. So 3 different architectures, 3 different reasons why you want to build an agent in a certain voice activated device, IoT Edge device in certain ways. So here are some resources for you. You can click the top link, get all of the code for all the demos that I had demonstrated here. If you're interested in hearing more about how to create a super easy button, create a RAG agent for me on DigitalOcean, we have the cool Gen AI platform. Click the second link. And then for all the speech to text and text to speech stuff, we have all of like some open source solutions and some paid platforms to take a look at. Otherwise, that would be the presentation.